When deploying WorkSpaces Personal across multiple AWS accounts and VPCs, you previously faced DNS name collisions because all PrivateLink VPC endpoints shared the same generic DNS name. This prevented you from properly isolating Workspaces directories in separate VPCs while using centralized DNS infrastructure. Now you can deploy Workspaces across multiple VPCs and accounts without conflicts, as each interface VPC endpoint receives a globally unique, publicly resolvable DNS name. You can eliminate DNS name collisions between endpoints, allowing proper security isolation for Workspaces personal directories in different accounts. You can route traffic appropriately in multi-account environments with centralized DNS infrastructure, as the unique names enable proper traffic routing. You receive AWS-managed DNS names with no configuration, as AWS automatically manages the lifecycle of these names without requiring Route 53 configuration or custom DNS management. The DNS names resolve to private IP addresses accessible only within the respective VPC, maintaining security while simplifying setup. Migrating notebooks between platforms and managing complex notebook workflows creates friction for data engineers and data scientists. You need to move existing work from Jupyter Lab and other platforms while maintaining productivity in large, complex notebooks. You can now import and export notebooks in IPNB, JSON, and PI formats while preserving cell types and metadata, enabling straightforward platform migration. You can reorder cells without copy-paste duplication, reducing errors and improving workflow efficiency. You can assign custom names to cells for improved navigation in large notebooks, making it easier to locate specific code sections. You can execute multiple SQL statements in a single cell with results displayed in separate tabs, allowing you to compare and analyze query outputs without switching between cells. These capabilities are available in all AWS regions where SageMaker Unified Studio is available. Building Java applications with async patterns increases cognitive load and maintenance burden for developers. Smithy-Java solves this by letting you generate type-safe clients directly from Smithy models, eliminating manual SDK creation. You can use a blocking-style API built on Java 21 virtual threads that matches async performance while remaining simpler to code. You can swap protocols at runtime, enabling gradual migration paths without rewriting code. You can also call Smithy services using a dynamic client that requires no code generation step. The framework supports AWS CGIF4 and all major AWS protocols including AWS JSON, REST JSON, REST XML, AWS Query, and Smithy RPC v2 KeyBR. Schema-driven serialization reduces SDK size while improving performance, and binary decision diagrams deliver latency improvements for endpoint resolution. Deploying applications on edge devices with limited resources has been a challenge, particularly for industries running complex AI and ML workloads in automotive, industrial IoT, robotics, and smart buildings. The new Greengrass component SDK solves this by reducing memory requirements from 30 megabytes to less than half a megabyte, enabling you to deploy on resource-constrained devices. You can use native C, C++, and Rust bindings optimized for performance and cost-critical embedded applications. This allows you to run complex AI and ML workloads at the edge where memory constraints previously limited functionality. The SDK maintains full compatibility with both AWS IoT Greengrass Nucleus and Nucleus Lite, ensuring you can integrate it into existing deployments without disruption. Managing authorization in multi-tenant applications requires tracking mappings between tenant identifiers and policy store IDs, as well as remembering system-generated IDs for individual policies and templates. This creates overhead and complexity as your application scales. Amazon Verified Permissions now supports policy store aliases and named policies and templates to address this challenge. You can assign human-readable aliases to policy stores based on tenant identifiers and use them directly in API calls. You can reference policies and templates by meaningful names instead of system-generated IDs. These capabilities eliminate the need to maintain separate mapping tables for associating tenant identifiers with policy store IDs. The result is simplified day-to-day policy management and easier authorization logic maintenance as your application grows. Customer-provided encryption keys, SSE-C, introduce operational complexity and potential security risks when managing encryption keys outside AWS. Amazon S3 now addresses this by implementing a new default security setting. SSE-C is automatically disabled for all new general-purpose buckets you create. For existing buckets and accounts with no SSE-C encrypted objects, S3 blocks new write requests using SSE-C. If your account has existing SSE-C usage, S3 preserves your current bucket encryption configurations without changes. This default deploys across 37 AWS regions including AWS China and AWS GovCloud, US, over the coming weeks, steering you toward AWS managed encryption options like SSE-S3 or SSE-KMS for simplified key management.